Okay, so today we're going to start talking about derivatives, but we're going to use the idea of limits. So the limit definition of a derivative. But really what you need to understand is the derivative is just a fancy way of talking about the slope. Okay, so let's say I have some function, okay, whatever that function looks like. And the derivative allows me to find the slope at a specific point. Let's say this is x, so I would find the slope at f of x right here. And let's say, I'll call this x plus h. So that means that this distance right here is h. And then this point right here would be f of x plus h. And the idea of the limit is I want to know the slope at a specific point. So the distance h is going to be getting smaller and smaller and smaller. So what I want to do is I want to find the limit as, h is approaching 0. Okay, but let's talk about what slope is for a second before I get into this crazy long equation. We know that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to do the same thing here. I'm going to find the slope between these 2 points right here. So my y is going to go on top. What is my y for this value? I'll call this is my x sub 2. This would be like my x sub 1. So my y value is f of x plus h. My second y value is just the f of x. And then my x's, my second x is x plus h. And my first x is x. So that's the equation. Let me simplify this. We want to know as the limit of h approaches 0 of f of x plus h minus f of x all over. Now, do you see how these two x's cancel each other out? So all I have is h on the bottom. So as h gets really, really close to 0, what is the slope going to be at that point? So let me give you an example. Let me say that f of x equals, let's say that f of x equals x squared plus 5x plus 3. Well, the first thing I'm going to have to do is, what is my f of x plus h? Well, f of x plus h just means I'm going to take this value and plug it in wherever there's an x. So there's an x here, so I'm going to say x plus h squared plus 5 times x plus h, and then plus 3. So we're just going to plug stuff in. Now we're going to subtract the top. You know, f of x, we're going to basically plug this into our equation. This is the famous limit definition of a derivative. So I'm going to first plug in x plus h. So I get x plus h squared plus 5 times x plus h plus 3. Now I'm going to subtract f of x. F of x is x squared plus 5x plus 3. And then all of that is going to go over h, because we know that our x's are going to cancel when we do our x sub 2 and our x sub 1, and you'll be left with h. So now let's simplify this. This is where our algebra gets really good. So I'm gonna square this, and hopefully you remember this is x squared plus 2xh plus h squared plus, now I'm going to do the distributive property, 5x plus 5h plus 3 minus, now I'm going to go ahead and distribute this negative to everything. That's minus x squared minus 5x minus 3, all of that over h. So now let's start cleaning up that numerator. The little secret is wherever there's no h, it's going to disappear. So see how this term does not have an h? Well, this term is going to cancel with this term, x squared minus x squared. 2xh has an h in it, so it's probably not going to disappear. There's no negative 2xh. Same with this term, but look at, here's a positive 5x and a negative 5x, a positive 3 and a negative 3. So what's left? What's left is all the terms with h's in it. 2xh plus h squared plus 5h all over h. That looks much cleaner. Well, now that I've cleaned up the numerator, I can now reduce because I can take out an h wherever there's an h. So if you're not familiar with this, I can rewrite this as 2xh over h plus h squared over h plus 5h over h, right? So I have to just take this h and reduce from each term in there. So the first term, the h's cancel and you're left with 2x. The second term, there's two h's on top and one on the bottom, so I'm left with 1h. And the last term, the h's cancel and you're left with 5. So that's it all simplified. But remember, it's from the limit as h approaches 0. So now when I plug in 0 for h, okay, if that becomes a 0, all that's left is 2x plus 5. So the derivative is 2x. The expression that represents the derivative is 2x plus 5. So what that means is I can plug in any value of x for this function that I've created, and I can tell you what the slope is at that particular term, at that particular space. So if in this case, if x equaled 1, I come over here, 2 times 1 is 1, plus 5 is 7. So the slope at that particular point would be 7. If I wanted to know what the slope was at 3, I would plug a 3 in. If I want to know what the slope is, okay? So I actually just made up this graph to show you the difference between x plus h and x plus 1. But the graph of x squared plus 5x plus 3, oops, where'd it go? The graph of x squared plus 5x plus 3 is more like this, like more quadratic. So you can see the slope gets steeper and steeper. Might be 7 here, 11 here. Let's put 5 in, that'd be 15 here. So the slope gets steeper and steeper and steeper. This is what worksheet 9 is going to have you practice, filling in this equation. So let me review the steps I did. So I did the steps. You're going to plug in x plus h for every x. Okay. The second thing is you're going to simplify the numerator. And then the third step is reduce by h, because you're going to usually the h on top with the h on the bottom. And then the last thing is plug 0 in for h. So for these 4 problems for your homework on worksheet 9, okay, you're going to go through this whole process and simplify it, see if you can. So this first one, it says, what is f of x plus h? Well, that one's, I'll do number 1 down here. I'll start it with you. It's just going to be x plus h squared, okay? Because all I do is take x plus h and plug it in for the x. The second one is going to be x plus h squared minus x squared. The third one is going to be x plus h squared minus x squared all over h. And now this is where you're going to simplify. Go ahead and start canceling this stuff out. So this is going to be very much like the problem we just did. I'll help you out. X squared plus 2xh plus h squared minus x squared all over h. Now if we simplify, look at how the x squareds are going to cancel. And then we can reduce by the h's. So you're going to get 2x plus h. Hopefully I didn't do that too fast. I subtracted the x squareds. And then I see that I'm going to cancel this h here, and I'm going to cancel one of those h's here. So I'm left with 2x plus h. But as my limit, as h approaches 0, this is just going to equal 2x. Okay, there's the first problem. You guys have 3 problems for homework. All right, enjoy this. We'll talk about if you have any questions tomorrow, and have a good night.